This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and my guest is Chandra Orrill, who's an assistant professor in STEM education and a research scientist in the Caput Center at the University of Massachusetts, Dartmouth. She's joining me today to talk about her article that's appearing in the Journal of Mathematics Teacher Education. It's entitled, Making Sense of Double Number Lines in Professional Development, Exploring Teachers' Understandings of Proportional Relationships. Thanks, Chandra, for being here.
Thank you.
So I want to actually start by backing up and asking you to describe your dissertation and your graduate school experience.
Okay, I did my doctorate at Indiana University under Tom Duffy, who, when I was there, was in instructional technology, and then went on to start the learning sciences program at Indiana.
Okay.
My dissertation focused on teacher professional development, specifically looking at how I could better support teachers in using computer-based simulations that were designed to support students in developing everyday problem-solving skills. So I created a professional development intervention, and I tried it out with two teachers and made refinements to it, and that's what the study was about.
Okay, great. But that was now a professional development study, not necessarily mathematics in particular?
Exactly. My training was not in mathematics education. After I finished my PhD, I spent a year at Ohio University as an assistant professor, and then was offered an opportunity in the Learning and Performance Support Lab at the University of Georgia, where I ended up going as a research scientist, and I spent 9.5 years there.
Oh.
The very first projects I was given at UGA were math ed projects. One was a systemic change initiative helping a school system that was trying to adopt major changes in their math ed program. And the other one was the Intermath project, which became a vital part of how I became a math educator. It's a professional development project also for teachers that has a web presence and a design for teaching teachers through engaging them in a series of they're closed-ended tasks that have multiple ways of working them.
Okay. And since that Intermath project is central to the article that we're going to be talking about, do you mind saying who was leading that project?
Sure. The PIs on the project were Jim Wilson at UGA in Math Ed, Mike Hannafin, who was the director of the Learning and Performance Support Lab, and Paul Omi, who was at Georgia Tech. And his group was... their acronym is SEISMIC, and they were in charge of the development of the web presence.
Okay. So you had several years working with that project, and obviously they're probably gathering data of lots of different varieties. And so that sets the basis for this current article that we're going to be talking about from JMTE. And I was wondering if you could just describe for us what it was that inspired you or led you to really look at this particular slice for the JMTE article.
So there were two different things that sort of led me to look at the double number line issue. The first was that I'm interested in teacher knowledge and how teachers use the knowledge that they have, rather than focusing on the knowledge that they don't have. I'm very interested in how are teachers thinking about this, how are they reasoning about mathematics. And then the other thing was I have an interest in representations, and I've noticed two things about representations that are kind of ongoing puzzlements for me. One is that teachers tend not to use them a whole lot in their classrooms. And the other one is that teachers tend to use them to show the answer instead of to reason about the mathematics. Oh. And so the double number line gave me an interesting place to look at how teachers actually learn to reason with a representation.
Okay, and so with that interest in representations, and we have the double number line, I was wondering if you could describe for the listeners exactly what this double number line is, just in case they're not familiar with it.
Sure. The double number line is basically two number lines. Each one is on its own scale, so you might have one that shows miles and one that shows gallons. And the idea is that there's a coordination between the values on the two lines. So if 1 mile is a quarter of a gallon, then 2 miles would be half a gallon, and 3 miles would be 3/4 of a gallon. And you can reason up and down with it in the same way that you might reason with a ratio table.
Okay. And you mentioned the scales are not necessarily the same, so this might be a new kind of way of using lines in this way? Because a lot of times there's a lot of emphasis on keeping the scales consistent, and here that's not the point. The point is to have that coordination between them.
Right. And the factor is the big important idea between the two lines instead of the absolute scale.
Okay.
You want to make sure that ratio is always maintained between the top line and the bottom line.
Okay, and in the article there's a lot of really nice pictures and tasks related to the double number line, so if people are interested in it, this article would be a great resource for learning more about the double number line. So, getting to the study of teachers' use and learning with this double number line through professional development, I was wondering if you could describe the data that you were looking at in this study and where that came from.
Sure. This was done as part of an NSF-funded project called Does It Work, which was a research project that capitalized on the Intermath project. And we offered 2 courses of Intermath during one semester in 2 different school districts. And the data that we used for this article is from one of those 2 school districts.
Okay.
We had 13 participants, and they taught... when we started, they were all between 5th and 8th grade teachers. By the time we finished, one of them had been moved to 4th grade.
Okay.
But we had 13 participants. They spent 14 weeks in the professional development, 3 hours per week. The facilitator had been a part of the Intermath project and had done extensive amounts of professional development around it before she taught this course. So we had a really experienced facilitator in there, and we captured every session using 2 video cameras. One was typically focused on whatever the written work was, whether it was on the whiteboard or the written work of individual participants, or on their computer screens, because we did a lot of work on computers. Mm-hmm. And the other one typically caught their faces so that we could see who was talking and what their facial expressions were and those kinds of things.
Okay. And then within those sessions, for this article, you're particularly focused on, I believe it was 5 sessions, is that right?
Right. And that was all the sessions in which the double number line was used.
Okay. And then not only focusing on those sessions, but also focusing on particular participants.
Right. This particular class was really interesting. 6 of the participants were very vocal and outspoken, and the rest of them rarely said a word. So the story of the double number line that we have to tell is really the story from those 6 participants, because they're the only ones who let us into their thinking.
Okay. I just wanted to mention, too, from the article that these sessions involved the double number line, but it wasn't sessions that were solely focused on teaching the teachers to use the double number line. The double number line was used as a resource in some, and it took different roles in the sessions. Is that right?
Exactly. Every session sort of Intermath sort of runs the same, which is there's 1 or 2 tasks that are given during the 3-hour session, and the participants spend a lot of time working on those tasks. And sometimes we suggest to them what tools to use, like the double number line, and other times we let them choose from, whatever tools they have available in their own personal toolbox.
Okay. So I'm speaking with Chandra Orrill about her article in JMT about making sense of double number lines in professional development. So you mentioned you have the story of the 6 vocal participants, but can you take us through that story? And in the article, you structure this with 3 different phases of the story. So I wonder if you could kind of just describe for us how those phases went.
Sure. The first phase was sort of the first 2 times they used the double number line, and very little instruction was given to them about the double number line. It was introduced to them, shown to them, and then they just sort of were expected to run with it. And what we saw in that first 2 sessions, which was the 5th week and the 8th week of the professional development, is that some strategies emerged. One was that the teachers tended to cross-multiply and then draw their answers on the double number line instead of reasoning with it.
So again, it's kind of I have my answer, and now let me draw a picture of my answer, sort of?
Exactly. Which gives you a nice picture, but it makes it kind of an irrelevant drawing at that point. Then the other thing that we saw was an approach using substitution. And we saw this in a few different teachers, but the clearest description I can give is one teacher drew a pie chart, and he divided that pie chart into 4 sections. And he said, if 1/4 of a serving is 2/3 of a bar, then I can write 2/3 in each of these 4 sections, and I can just add 2/3 up 4 times, and that'll give me the answer. So he had basically substituted the number 2/3 in place of this serving size, which is not exactly what we're hoping for in proportional reasoning. So he sort of dropped one of the quantities and only paid attention to the other one at that point.
It's almost sort of circumventing proportional reasoning by making the substitution and then just reasoning basically linearly with the new quantity.
Exactly. And then we saw that a couple teachers were using what we think were probably build-up strategies, where they drew the number line and then they extended it and they put 2 new numbers on it, and they extended it and they put 2 new numbers on it. And we think that they were probably using the same kinds of reasoning that young children use when they start using build-up strategies.
And so that's phase 1, and then phase 2, some new things started to happen, right?
Right. So phase 2 is really interesting. The facilitator went in and just opened a dialogue about the double number line. She had been sensing that the participants were unhappy with it, and she was like, okay, let's talk about this. And through this discussion and through her insistence that they were going to use the double number line to reason, she really created a lot of perturbation for them, which gave us a beautiful set of data to really understand the problems that these people were having making sense out of it. What we saw was, through this very overt action of opening up a discussion about what do you see here, what do these numbers mean to you, how can we reason with this, we saw the beginnings of the teachers starting to make connections. And we knew they were the beginnings because what we saw was things like one teacher who had been using partitioning for the 8 weeks leading up to this with fractions with no problem at all, got up and said, I think we need to partition. And she went up to the board and she drew her double number line, and she just started drawing all kinds of lines between the 2 number lines. And there's a picture of this in the article where you can see there's just a ton of lines. So she's trying to partition it, but she hasn't quite figured out what it is about partitioning that she needs to pay attention to in order to actually reason with these double number lines. So I see that as the beginnings of connection making between ideas that they already have to this new context.
Right. And in phase 2, what's the role of the calculation now that you said they were pretty facile with calculation in phase 1?
Right. In phase 2, the facilitator got frustrated with them trying to use calculation. She finally said, don't use calculation. I want you to reason with this. And I think that was incredibly frustrating for the participants, but it got them actually reasoning, at least somewhat, with the double number line. And it got them to understand what the relationship was that double number line was starting to show them.
Okay, so there's these perturbations, and there's the facilitator making explicit efforts, and those possibly contributed with some other things as well to reaching phase 3. So could you go ahead and tell us about phase 3?
Sure. In phase 3, we saw some evidence that they were starting to be able to reason with the double number line. We had one participant, there was a situation where we asked about a relationship of 2 different colors of paint to each other, and it was a ratio of 3 to 2. And he drew a beautiful double number line that had the top line divided into half. Every segment was divided in half, and then the bottom line had thirds for every half, so you could see where these would line up, and you could create sixths, and you could come up with really nice relationships between them. And he did that without calculating first. It was the first time that we had seen this particular participant do this. Of course, the next week he went back to using it as an estimating tool. Okay. So it was still very fragile knowledge. But he had the ability to do that, which was new. We also saw that they were starting to understand that the partitioning was reliant on finding a common denominator. And that really, when they made that connection, that really opened up the door for some of them to be able to actually coordinate the values on the 2 lines in ways that allowed them to reason with it.
And to get to some more useful partitions, as opposed to partitions that are less helpful.
Exactly. So it wasn't just random partitioning anymore. Now we were getting to some partitions that would actually let us reason about the relationships. And then we still saw some evidence of the estimation. One of the participants said, for example, as he was drawing his number line, he's like, oh, one batch is hitting right about 2 1/3. And that was the kind of estimation language we were hearing. It wasn't, oh, one batch is 2 1/3. It's right about there. And he drew the lines separate from each other. They weren't linked in any way, and he would put a box around them to show that approximate relationship. So in phase 3, we definitely saw some major steps forward, but we still saw the pervasiveness of this idea of estimation, and still trying to make sense of things in odd ways.
Okay. And still some participants that are wanting to stick to sort of an additive way of reasoning about it, where they maybe substitute for the value and then they just can iterate it rather than really coordinating proportionally.
We saw some of that, and then we saw some people who were going back to doing cross multiplication and drawing the answers.
Okay.
One of the really interesting things that came out of phase 3 for me, besides the fact that we were able to finally see that they could do this, when they had to, was that they didn't apparently see the reciprocal relationship between the double number lines. So they started out thinking about the relationship of the top line to the bottom line. And they didn't think about the fact that you could also go bottom line to top line. So when they started trying to make that backwards relationship, they drew it as a whole new problem and worked it as a whole new problem. And it was new to them. They were surprised. One of the participants was outwardly surprised when he figured out that he could use the same double number line pair to figure out both of those combinations.
Right. And speaking of new to them, we should mention that none of these teachers had used the double number line before, right? It was a new representation.
Exactly.
Yeah. Okay. So thinking across the three phases, in the article you summarize across the three by talking about that there was a lot of knowledge brought to the table by these teachers, but some of the knowledge was more useful in promoting this new way of thinking or the new use of the representation of the double number lines, and other knowledge that they brought was less helpful.
Right.
So I was wondering if you could kind of talk us through that summary as well.
Sure. What we figured out was that some of the useful knowledge they used was the ability to coordinate units. So because of the kind of data we have, we're really reluctant to call it composing units, which is sort of the formal position we want people to get to, where the two units become so interconnected that they can't really be separated. We don't have data to tell whether or not they were doing that. But we do have data to tell that they were actually attending to the fact that there was a relationship between the units on the top line and the units on the bottom line, or the quantities on the top line, quantities on the bottom line. So we saw that as being really, when they did that, that was really useful for them to reason both about double number lines and about the proportions, rather than like using substitution where they just dropped one of those quantities.
Right.
Another kind of useful knowledge was the partitioning. They had been using partitioning in fraction activities for weeks before we did this. And so it was nice to see them bring that knowledge into the double number line, because that if you have an amount on your double number line, you want to find half of that amount, you're going to have to partition it. And so it was exciting to see them be able to use that knowledge. What we found to not be as helpful, one thing was the issue of scale, and the notion that they really got tripped up on the scale of the double number lines because they wanted the scale of both lines to be the same,
Right.
rather than the relationship, the ratio to be the same. And so that really confused them for a while.
Well, and some of them, if I remember, were even saying they were afraid it would confuse students, and so they seem to have a concern for the students. Is that true?
Right. They were afraid that would be very confusing to students. And I've seen teachers in other situations who participated in the other site for this, who also had issues with scale and not knowing how to make that work. So I think that's a place worth paying attention to in using these kinds of representations. Another piece of unhelpful knowledge was using estimation. The teachers are very good at estimating, but for some reason they thought that it was appropriate to use an estimation strategy to compare the values on the two number lines, rather than saying, no, this is a ratio. These are numbers that are locked together in a way that isn't an estimation. It's an absolute relationship. So they sort of lost sight of proportions because they were trying to use estimations to make the representation work.
So it's almost like they could rely on estimation to get a reasonable answer rather than using proportional reasoning to get the exact answer.
Right. And then the last thing that was unhelpful was calculation strategies. The calculation strategies just undermine reasoning. And the whole point for our using the double number line was that we wanted to support proportional reasoning. And if you're just going to calculate the answer and draw it on the number line, then you've just undermined that entire step.
So the fact that they were so adept with the calculations and they knew how to compute the answer, it took some time and some effort on the facilitator's part to get them to really engage with the double number line in a rich way.
Right. And I think when she finally decided to say, quit doing that, you have to reason with this, was probably a major breakthrough. And we didn't prep her for that. We didn't tell her to do that. She did it on her own, but I think that it was a really great decision that she made on the fly.
I'm speaking with Chandra Orrill from UMass Dartmouth about her article in JMTE, which is entitled Making Sense of Double Number Lines in Professional Development, Exploring Teachers' Understandings of Proportional Relationship, and that article was co-authored with Rachel Brown. But I wanted to ask you, Chandra, if you could give us or identify a key takeaway point or an idea that you'd want to leave with the readers of this article.
Yeah, I think the big idea that I hope people walk away with is that we spend a lot of time focusing on what teachers don't know. And this article shows that teachers have a lot of knowledge that they bring to situations, and they're working from a position that is internally logical to them with the ideas that they're using. These teachers brought a ton of different ideas to the use of double number lines. They just weren't the ideas that we as the math educators were expecting them to use. So I think that we need to focus on what they do know rather than what they don't know and sort of build from there instead of treating everything as a deficit model.
Mm-hmm. And you, in the article, you rely on the theoretical perspective of knowledge in pieces from DeSessa and others. And I think you do a nice job in the article of talking about how there is this knowledge and it's not really about what they have or don't have. It's about how they draw on that knowledge and how they integrate it and organize it. And,
exactly.
And through this, through your data, you're showing how the teachers were going through the process of, okay, I have a lot of knowledge, but how can I integrate that knowledge with this new representation of the double number line?
Right. And I think that the example in phase 2 of the teacher who got up and drew the tons of partitions is exactly that kind of situation. She knew that partitioning was somehow important. She knew that she knew how to partition. She just hadn't quite coordinated it with how does that show this proportional relationship. And so she tried it. And she realized, wait a minute, I don't know what I'm doing. But it opened up a discussion among the class of, wait, partitioning. We haven't thought about that.
Mm-hmm. Right. Chandra, thanks for being here, but I do have one more question before I let you go. And I ask this to everybody. It's a question from Aaron Brakenecki at Michigan State, my friend and colleague. But if you were not in math education, you eventually made your way to math education, but if you didn't find yourself in this profession, what do you see yourself doing?
You know, I think I would probably be a professional musician.
Oh.
I started in college as a flute major, and over the years, and I've sort of transitioned from being a flutist to being a bass player. So I would imagine that I would probably become a bass player. Now,
Flute's kind of more orchestral, and for bass, do you mean kind of orchestral bass, or do you mean more like jazz bass or rock?
Well, what I play now is orchestral bass because that's what I'm most trained in from being a classically trained flutist. Oh. But if I were to do it professionally, I think I would try to be in like a swing band. I think that would be a blast.
Yeah, and that also, so you've had treble clef and bass clef, so you have some versatility there as well.
Yeah.
That's great. I've been speaking with Chandra Orrill from UMass Dartmouth. Thank you so much for being here.
Thank you.